When light is shined at chromium or any metal, electrons can be ejected from the surface. How fast are those electrons going to be moving? I'll show you how to calculate it right here. The light has a certain frequency, or wavelength, or energy, and the metal will have a certain energy. That energy, the binding energy, is the energy required to remove the electron from the atom. Where is that electron going to come from? From photons of light. But what happens if the light photons have more energy than necessary? Well, it uses up this amount of energy just to remove the electron from the atom, and the rest of the energy is now kinetic energy, and the electron flies off of the metal with a certain speed. So, the leftover energy of the electron is going to be the amount of energy in the photon less the binding energy. This shows that it's the amount of energy left over, and we can take that leftover energy and calculate the speed using the formula for kinetic energy, 1/2 mv squared. Now, I've rearranged that so that you can just plug in your energy and the mass of the electron to get the speed. But let me show you how we do this. So first of all, we need the energy of the light. How do you calculate the energy of light based on frequency? The answer is E equals h times nu. H is Planck's constant, 6.626 times 10 to the negative 34 joules seconds. And they gave us the frequency 1.2 times 10 to the power of 15 hertz, or seconds to the negative 1. When you do that on your calculator, you get 6.626 times 10 to the power of negative 34 times 1.2 times 10 to the power of 15. I get 7.95 times 10 to the power of negative 19 joules. That's the energy of my light. The energy of the electron, or the energy left over for the electron, is that amount less the binding energy. So, the energy of my electron is going to be 7.95 times 10 to the minus 19 joules minus the binding energy, 7.2 times 10 to the negative 19 joules. When I do that on my calculator, I get 0.75 times 10 to the negative 19 joules. And here's where the new formula comes in. This is the amount of energy left over. It becomes kinetic energy, which is 1/2 the mass of the electron times the speed of the electron squared. Put another way, the speed of the electron is the square root of 2 times the energy over the mass. I just rearranged the formula for you, which gives the square root of 2 times 0.75 times 10 to the negative 19 joules divided by the mass of an electron, 9.11 times 10 to the negative 31 kilograms. It needs to be in kilograms so that the units cancel out with joules. So, what I have is 2 times 0.75 times 10 to the power of negative 19 divided by the mass of an electron, negative 31, 9.11 times 10 to the negative 31. And then I take the square root of that. I am left with, it looks to me like, 405,776 meters per second. Not even close to the speed of light, but still pretty darn fast. Electrons move fast. And that's how you calculate the speed of an electron from the energy of the light and the binding energy of a metal. Best of luck.